Falco's here to save the day. Open source in every way. Runtime security's the game. Bringing threats to fuel the flame. Revolution in the air. With each code we boldly share. Detection quick and so precise. Response that's sharp as ice. Falco project spotlight shining in the night. Catch those threats in sight. Always ready to fight. Community strong and bright. Coding through the day and night.
Hey everyone, and welcome to another Cloud Native Club Project Spotlight series. Today, I'm excited to have with me Thomas from Sysdig, and we're going to explore Falco. Thomas, thanks very much for joining us. Could you briefly describe yourself and share what drew you to the Cloud Native space?
Yeah, sure. Currently, I'm a Falco maintainer, but before that, I was just a member of the Falco community. My previous job was basically SRE for 10 years. I manage infrastructures for customers, but most of them were involved in the online businesses field, some media press, but most were for online shops. I also did some online banks as SRE/DevOps. So I used Falco in production for some years. I developed on my free time some tools around Falco to enhance the user experience. And after a while, Sysdig, the company which created Falco at first, they proposed me to join them and become a dev role for the project.
That's awesome. So for those who might not be familiar or aware of Falco, could you briefly introduce it and kind of explain why you and the team think it's essential for cloud native environments?
I think I will just move on with my slides. I have everything on the slides to explain what Falco is and how we can, what are the benefits to use it. It will be easier to have images.
Let's switch to the slides and I'll ask a couple of questions as we go.
Yeah. So in this talk, we talk about Falco and its ecosystem and how it can help you to improve the security in your Kubernetes clusters. Not only Kubernetes world, because as long as you have kernel Linux, Falco can run on it, but the main usage right now is to use it inside Kubernetes. First, we need to understand in which fields Falco evolved, right? It's a domain called runtime security. So basically, by these terms, we are talking about all tools, procedures that helps you to secure your applications when they are running. So it means it's a tool for the production. It's not like a discrete tool like an image scanning, which happens only in your CI. It happens all the time by checking in real time what is happening in your clusters and try to detect in real time suspicious events, possible threats. So this is a SenseF project created by my company Sysdig 7 years ago, I think. We are the most advanced, most popular tool for runtime security is a CF project. And the last April of this year, Falco got graduated. It means the CNCF considers Falco is stable enough, resilient enough to be a standard for runtime security. How does it work? So basically, first we need to explain what syscalls are. I don't think all people among the attendees are really familiar with what syscalls are. So syscalls are basically system calls when an application in your system needs some access to a physical resource. By that, I mean the application needs access to some time in the CPU for calculations, needs access to the network, to some blocks in your hard drive, in some blocks in your SSD. To get this access for write or read, the applications will ask the core of the system, which is the kernel. The kernel is in charge to tell, okay, you have access, you do not have access. Wait for your neighbor because he's writing or reading that exact same block, that exact space of memory. All these calls are made through what we call system calls. So basically, you can consider the system calls like the API of your kernel, the way to request something to the kernel. You have a question and an answer. So if you can collect real-time all these syscalls, it means technically you can see everything that is happening in real time internally in your system. And this is exactly what Falco does. To do so, we use eBPF. eBPF means Extended Berkeley Packet Filter. It started in the BSD world as a network system to collect network packets and to do some analysis, some monitoring, and then security. But then they introduced that the Linux kernel, and it's now pretty commonly used for security monitoring, diagnostic. Basically, the idea of eBPF is to inject, without any recompilation, rebuild of the kernel, some few programs inside the kernel to do some stuff. Your eBPF program will be checked for some sanitization. For example, the kernel will be in charge to check if you don't introduce infinite loops, memory leaks in your program. If all checks are green, the kernel will accept the eBPF probe and will run it inside a minimal sandbox for security purposes. The eBPF probe will be hooked to some endpoints in the kernel, and these hooks are populated by the kernel with some informations, one for the security calls, another for the for metrics, another one for networks, etc. So we are connected, Falco is connected to these endpoints, to these hooks, to get all the information about the ongoing syscalls. To give you a basic internal architecture, overview of the Falco's internal architecture, we have in the kernel space the eBPF probe in charge to collect these syscalls. These syscalls are then put inside a ring buffer, a memory ring buffer, and Falco is running in the user space. It means only the part in charge to collect the syscalls will be in the kernel space. All remaining actions, for example, the check, the collection of the of metadata, the comparisons with the rule engine, everything is made in the user space for security purposes and also for performance purposes. By having this kind of architecture, we are sure we will not impact the kernel performances. So the syscalls are in this ring buffer, and the first internal library of Falco is in charge to collect these syscalls. Then it will pass them to another one called limpsys. Impossible to tell, to be honest, limpsys, the name is horrible, but the purpose of this library is really important because this library is in charge to enrich all syscalls events with metadata that us humans will find really useful to get some context and to write rules. These metadata are basically the container ID, the container name, the container labels, but also the pod names, the pod labels, the pod namespace. All these things which are totally irrelevant for the kernel, but really, really useful for us as humans to create rules that makes sense. For example, you can whitelist a namespace in Kubernetes. You can target only some tags, some labels, whatever. And then the final stage in the internal Falco's internal architecture is the rule engine in charge to do the comparison between the events enriched with metadata and the rules we set up. And then if one rule matches, it will trigger an alert. And then we'll see what we can do with this alert. So just another overview without the internal aspect. So once Falco has triggered something, we can forward the alert to the standard out. Useful if you have FluentD, 5-bit, Logstash in charge to collect the logs from your pods. You can send them directly to a file. to a program. So it's basically like sending them to a pipe something. Syslog, if you are using a local syslog or remote syslog server, you can forward the log, so the events to this syslog server. HTTP to forward the logs to an external endpoint, and gRPC. gRPC a little bit particular, but we also have that.
Yeah, so you've obviously got a flow there, right? You're doing the kind of event, the main event collection, which is being done with eBPF. You're like the kind of the man in the middle, or the tool in the middle that's doing the kind of rule matching, and I'm sure we're going to come on to that.
Yeah, exactly.
And then you're going to fire success or failure. Is that correct? So you can fire alerts on both positive and negative.
You will just have an alert if rule matches with an event. So if nothing, if we don't have any correlation between a rule and an event, nothing is triggered, nothing is fired. It's totally transparent. So this is a real example of a real rule of Falco. So even if you're not really familiar with Falco and not even familiar with what syscalls are, you can understand quite easily what is the purpose and what to do with this rule. So first we have the field, the key rule. This is the name of the rule. You will have this in the alert. It is also useful for us to know what is the context. The description is just there for us humans to help the rules writers to know what is the purpose of the rule. We have the condition, the output, a priority. You can filter by priority, and tags. Tags are also useful to filter, to enable just a subset of rules. And if you are using a SIEM like Elasticsearch to do some search to get, for example, I want just alerts that concern containers, that concern network, for example. You can see, I think it's in the output. This is the output message, is the exact message you will get in the alert at the end. And you can see some elements start with a % sign. They are blue. If we have some people with color blindness, they start with the % sign. All these elements will be automatically replaced by Falco to give you an output with the whole context you need. And all these elements we call them fields. You can also use them in conditions. So even if you're not familiar with Falco, it's easy to understand user.name means the name of the user. Container info, it's all info like the labels, tags of the container. Of the container, proc.name for the name of the process, proc p-name for the name of the parent of the process. So it's pretty straightforward and easy to understand.
So Thomas, are these specific to Falco, these fields, or are they fields that you can
Yes, these fields are specific to Falco. You, in the falco.org website, in the docs section, you have the list of all fields which are available to create rules, conditions, and you can use them in the output. And we have another step. If you can take a look at the condition, spawn dash process, container, and shell procs, these elements are not offered out of the box by Falco. They are what we call macros and lists. Basically, to detect a new process has been spawned, this is always the same. We are using the same fields and the same filters. It's event type in this list, and the direction is in this one. Basically, it's a request to the kernel, not a response from the kernel. So instead of repeating this block over and over, you can just create a macro and reuse that macro from one rule to another. So if one day you want to extend this macro, it will be replicated, it will be propagated to all rules which use that macro. We have the same for the list. For example, this is a list of shell binaries, and this is a macro which uses this list. So proc.name in shell binaries. Of course, everything is extensible. And
are these custom macros and lists, or are these ones that already exist upstream?
This is my next slide, because it's really hard to write from scratch some rules. Us maintainers and also the Falco community, we are providing to the end users a list of out-of-the-box rules. Right now, we have something like 88 different rules. Then don't have the same maturity. We are following the CNCF systems for maturity: sandbox, incubation, and stable, which means graduated. So out of the box, not all, in a vanilla installation of Falco, not all rules are enabled, but we are trying to cover the most common patterns we can find from the attackers, which are privilege escalations, the access to sensitive files, to try to mutate some binaries, create symlinks, etc., etc. And we provide these rules for the community. Everyone is welcome to contribute, of course. And you can use them, and you can also extend them to your system. For example, if someday you want to exclude the kube system from the rule I showed just before, you can just add this block in a custom file, and it will override the default rule. So everything is extensible, and you can override anything by appending elements or by just replacing totally the rule. I think it's clear enough. So this is an example of a rule created by an alert created by the rule I just showed in my previous slide. You have a timestamp, of course, the priority, and the output message with all fields completed by Falco to get the context. So you have the user, the ID, UID of the user, and the container info are there, the image, the tag, container name, the namespace, the botnet. Everything is there, so you have the whole context, and you know where you are supposed to dig after.
And if I wanted to, could I choose the output type? So could I output that whole alert as JSON if I wanted to, or is it a standardized format?
Totally. If you want more information, and if you, for example, if you want to include the name of the rule, the name of the source, we'll see why we have a source field in the JSON. And also, if you want to get all elements that have been replaced in the output message, you can enable the JSON format. And so you will have in a more consumable way for format the Falco alert. And this is really useful if you want to send that to Elasticsearch or else. So of course, we offered a JSON output. It's much easier.
Yeah, more
in the last,
machine readable.
Yeah, exactly. In the last 2 years exactly, we thought, okay, we have Falco, it can collect syscalls quite easily. But at the end, Falco, the core system of Falco, is not the collection of syscalls because this is made by the BPFROP. Falco is a rule engine. We could ingest in Falco other events, other streams. So we integrated a new plugin framework inside Falco. So if you're in, we developed in SDKs in CPP, Golang, and Rust now to collect and ingest any stream of events you may have. For example, we collect from the control plane of Kubernetes, the Kubernetes audit logs. If you are using managed clusters like EKS or GKE, you don't have access to these audit logs directly because they are collected by the cloud provider. They are stored in something, CloudWatch logs, Stackdriver, and you have to pay for the storage and for the request to the API to collect them. But we provide anyway plugins to collect these audit logs from the log storage system of your cloud providers and inject them back in Falco. We also have that for CloudTrail. We developed with HashiCorp a plugin for Nomad. We have Docker, which is basically a dummy plugin to explain how to develop a plugin. We have Salesforce, Kafka, GitLab, and also a guy met me at the last KubeCon EU in Paris, and he was really happy because he developed a plugin which replicates a remote syslog server. So it means you can forward by the syslog protocol all your logs to Falco. And then with logs, with some rules, you can detect suspicious things among these logs.
That's awesome.
We have GitHub, Okta, and for fun, I developed Bitcoin just to show we can subscribe to WebSocket and get real-time events. More and more plugins are developed by the community and by the maintainers. If one is missing, you can ping us and we can see what we can do. For example, right now I'm developing the AKS for Azure. So basically, with one tool, Falco, the same syntax, you can collect events and do some and trigger alerts for suspicious events for so many different layers. With syscalls, you can detect suspicious things at the application level. With the EKS plugin, you can collect the events from the control plane. With Kafka, you have all the sources. With CloudTrail, you have also your Amazon account. With GitLab or GitHub, you can also detect attacks in your supply chain. For example, if someone is trying to disable the MFA in your repositories, in your GitLab or GitHub account. If someone is deleting a repository in your organization, you can detect that. And if for all these systems, you are using an SSO system like Okta, you can also use Falco. So with only one tool, the same syntax, you can protect or detect suspicious events, possible threats from all these sources. So it's totally extensible. And before Elon bought Twitter, we also had a Twitter plugin. So in my demos for my talks, for example, people were able to tweet with a specific hashtag, and in real time, their tweets were collected and exposed by Falco in my back. It was fun. No one sent some no safe for work stuff, but it worked.
Yeah,
no, we have to pay
dangerously
to
there.
get the. Yeah, exactly. But not all talks are recorded, so it's always okay. So this is the global overview of Falco. So this is the image of the architecture. At the bottom of the file, yeah, you can see, I think you can see it. We have Falco CTL. Falco CTL is a tool. I will not explain exactly what it is, but globally, this is a tool that will help you to manage life cycles of the rules and plugins for Falco. You can use it to package the rules, package the plugins as OCI artifacts, push them into a registry, and it's also able to, it runs as a sidecar in the Falco deployment, and it is in charge to check regularly if we have new rules in a repo and download them, check their validity, and inject them into Falco. So basically, it's a way to manage life cycles of plugins and rules. I could explain that later. Okay, so know how to connect Falco with your existing ecosystem, because we have no Falco triggering alerts. What to do with these alerts? And we have a tool called Falco Psychic. Basically, Falco Psychic is a proxy between Falco and the rest of the world. Falco Psychic is in charge to collect the events from Falco and forward them in a fan-out mode to, right now, we have something like 74 different integrations. So you can take the alert, forward them to Slack to notify your SRE, DevSecOps, or else. If you prefer, you have Teams. We have Teams in a Teams integration. You can forward these alerts into Loki, Elasticsearch, QuickWit, Sumo Logic, CloudWatch Logs, Datadog, and we have a lot of different integrations. Kafka, NATS, if you use a queuing or a message stream system. We also provide metrics and on-call system. So I was SRE before, so trust me, I was welcomed by Falco sometimes. Yeah, with PagerDuty at that time. We have call storage, object storage with MinIO, S3 or else. And we also have function as a service, serverless. The classic one, Lambda, Google Function, Cloud Run, Tecton, Argo Workflow. We have a lot of different integrations. If one is missing, you can just create an issue and we'll see we can integrate that into Falco. But technically, we are covering a lot of different acts of systems, the most common ones, at least, I hope. So all your Falco fleet can forward their alerts to the same Falco Psychic. Falco Psychic can inject in real time some metadata in the JSON payload. For example, the cluster name, because from the kernel perspective, from Falco perspective, they don't know the name of the kernel, but you can use Falco Psychic to inject them. Since the last version of Falco, we can also do that at the Falco level. It's possible now to set up in the Falco.yaml, the config file of Falco, which element to inject in all fields, in all outputs, for example. Sorry, this part is still in French. I will change that after. But you can forward the alert thanks to Cyclic to all the alerts to Elasticsearch to create some statistics to have them in some nice dashboards. We know managers love dashboards. So and you can forward these alerts to Elasticsearch to Opsgenie or your on-call system only if the priority is above a threshold. So you can filter like that, and you can pull Falco Cyclic to get some Prometheus metrics. I know with the last version of Falco, we also expose Prometheus metrics at the Falco level.
Is that at the Falco level or the Falco sidekick level, Thomas?
Both. Before that, only Falco Cyclic were able to was exposing Prometheus metrics, but now we are also providing metrics at the Falco level. Before that, we used a tool called gRPC Exporter. It was in charge to connect itself to the Falco gRPC endpoint, collect events, and export metrics. But now Falco exposes slash metrics and give metrics in the Prometheus metric format. A particular output for Falco Cyclic is Falco Cyclic UI. This is a basic interface. It's not made for production purpose, but it's there to, if you install Falco out of the box, you can enable it and you will have a basic overview of all alerts Falco triggered. And you can filter, you can click everywhere, you can search, just to help you to understand how it works and to help you to tune your rules, for example, by adding in your rules some whitelists or allow list or deny list, just to be sure to be relevant with your ecosystem. For example, if you know this process, it's legit that this process, for example, Argo CD, it's normal for Argo CD to call the control plane API. So you can add this in your whitelist to avoid false positives. And once you, after a while, you will get only legit alerts. So I will try to show you the UI anyway. So another overview, we have this architecture for Falco Cyclic, the plugins, Falco CTL, and Falco Cyclic UI. The last step, which is the most logic one, is, okay, we have the detection, we have the notification, we are also able to visualize. The next step is to react.
Yeah. Fortunately,
with Cyclic, we have the integrations of Lambda function, OpenFast, Knative, basically fast and serverless. It works and you can do whatever you want. It's really modular. We have, this pattern, we call that response engine. We have some benefits. For example, you have a total flexibility because you can connect Falco and Cyclic to whatever. You can develop in your own way the functions. You have a total control over them. You can do what is relevant for you. You are not really dependent on third parties, except the cloud provider or tools, but you don't need to install something else, like a system in charge to do some workflow or else. And if you are already familiar with these serverless files, or else if you already have some procedures, a CI in place to manage these functions, you can reuse what you already have in your company. On the other side, you need to develop everything. You need to manage the errors, the notifications, the logs, the notifications. And if you are familiar enough with the Kubernetes SDK, you know it's not straightforward to develop and manage correctly the complexity of this SDK, especially for the authentications, errors, and so on. If you are not already using these systems, it means you need to deploy a CI for them. You need to deploy them, to manage them. So it means you need to collect the logs, to manage the metrics, everything. And if you use an external system, you may have some latencies. For example, the cold start of Lambda functions. And if you want to chain actions, for example, do sequential actions, you have to prepare the development for that. You have to prepare some queuing system, some messaging system between your functions. It's not so easy. This is why, yeah.
Oh, you've already, okay, now it makes sense.
Yeah, this is why we created a project called Falco Talon. And this is a tailor-made response engine for Falco, a no-code response engine. It means you don't have to develop anything. You just need to configure rules. These rules will be in charge to do the correlation between an alert and the actions to perform to remediate. So you can forward the alert directly from Falco or from Psychic, and then Talon will be in charge to call the different APIs of Kubernetes, but we also have other integrations. You will get notifications, logs, metrics, a lot of stuff. So to give you an overview of the advantages of Talon, like I said, zero code. Just need to write some YAML rules.
Of course.
Falco Talon comes with out-of-the-box actions. First, we focused on Kubernetes, but we can do more. So you can terminate a pod, add a label, modify a label, or delete a label from a pod. You can create a network policy, execute a command, run a script, get the logs, delete whatever, config map, secret, user, whatever. You can also run a TCP dump. You can call down a node, and then you can drain a node. You can download a file from a pod. And if you are using Calico or Cilium as CNI, you can create a Calico network policy or Cilium network policy, and you can also trigger Lambda function. All these actions are triggered, and the triggers of these actions are based on priority, the tags, the source name, the Falco rule name, the output field. You have a fine granularity to be sure to trigger the action only and only if it's relevant for you. All actions can be sequentials, and for some of the actions, for example, to delete, to download the file, get the logs, you can export these artifacts to S3 or MinIO. And we have out-of-the-box notifiers, email, webhook, Loki, Elasticsearch, structured logs, and OTLP, so OpenTelemetry traces, metrics, and Prometheus metrics.
So before we go any further, I just want to say, I know, but when did this actually become a thing in the Falco project?
I started this project, I think, 2 years ago on my side. So basically, I created Falco Psychic to get better notifications. Then I created Falco Psychic UI to get a better visualization for my talks. Then it became a bigger project. And then I created Talon because I thought it was my last step in that field. It started to become a bigger program, I think something like 6 or 7 months ago, when another developer joined the project and helped me. And yesterday, after a vote, positive vote from the Falco community, Talon became an official project of the Falco organization since yesterday.
Congrats.
So now this is the official way to create a response engine with Falco. And I hope it will grow and more in the future. Hope so. So this is an example of a rule from Talon. I tried to replicate as much as possible the user experience we have with the Falco rules. So we have a rule name. This one is a Talon rule, it's not a Falco rule. We have a max section, like in Kyverno policies, for example. So this rule will be triggered only and only if the event Talon receives concerns the right below etc rule from Falco, and the namespace name is not kube system. If the event is relevant with these fields, with these filters, we'll do 3 actions. First one is download the file. And we see we don't have any detail. Why? Because all details are there. Like for macros in Falco, we have action blocks in Talon. These action blocks can be reused from one rule to another. And as you can see there, you can override them at the rule level to be relevant with the context. Smart. So in that situation, we download the file, we have the what we call actioner. Actioners are out-of-the-box actions. The parameters, it should not be output, it should be parameter there. But no, it's okay, it's output, sorry. Output, we target S3, the packet Falco -talon, and with the prefix, so the folder in S3 will be /logs to download the file. It should be file. I changed the slides yesterday and I forgot that, sorry. And then we delete the file. So we use another actioner. And this actioner, you see, we use that environment variable. Why? Because Talon will populate some environment variables to give you access to them and to be dynamic. So basically, fd.name is the name of the file detected by Falco. You can have this field in the event. And this field will be used as environment variable like fd_name, and you can use it in your rule. So if this rule is triggered, if another, you don't have a static name for the file. It's totally dynamic. So we use shell and we do just remove, basically. And the last step is to terminate the pod. But we have some controls, some guardrails, I think we can say that, which are, if the pod belongs to daemon set, ignore it. I prefer to just notify everybody something bad happened. I collected the file with the previous action, but I will not terminate it because I could do some bad stuff for my production. Same if it belongs to a demo stateful set, or if you don't have enough LC replicas. We have some controls to avoid to break the production. I was SRE for almost 10 years, 6 years of on call. So I don't want a system which will break automatically my production.
I like these parameters a lot because I've dealt with similar situations, and yeah, they're
exactly.
the don't wake me up at 3 a.m.
Exactly. So I prefer to be conservative about that. get the notification and check myself. But I'm sure I downloaded the suspicious file in few milliseconds. So I can read it after, study it after to understand what it was. If the pod is terminated, when the next day, at least I have the context. I can investigate and write my incident report because I have the context. So we have this global ecosystem right now. Maybe it will be extended in the future, but at least we have that. So the next step is to run a demo. I hope it will work. I will try to explain everything. So I just restart the port forward. So as you can see, I have Falco Cyclic UI. So a little bit slow because I'm sharing my screen, but it should work technically. Oh, I don't have, okay. I'm supposed, okay. Let's hope it will work. So I'm running, sorry, a 5 nodes Azure cluster. Falco is connected to the kernel. It means we have 5, 1, 2, 3, 4, and the 5 is there. 5 Falco. It's deployed as a daemon set to be sure to have 1 Falco pod deployed on every node of your cluster. Just to be sure, because the kernel is not shared across the nodes, so you need 1 Falco per node. We also have Falco Cyclic UI, the front-end backend you can see there, and the data backend, which is right now Redis. I will change that because I'm not a big fan anymore of Redis for different reasons. And we have Talon. In this situation, Cyclic is deployed with only 1 pod, just because I wanted to save my resources, but you can enable high available replica with 2 or 3 nodes for Cyclic, same for Talon. Mm-hmm. So I will list my pods in the default namespace. I have this pod called cncf-something, and you can see the labels there. I will exec into my pod to get a shell. You can imagine someone was able to exploit a CV in your beloved WordPress and get a web shop. I will simulate that. So I will just show you the Talon logs and full screen. You see, in less than 1 millisecond, Talon receives the event there, an event terminal chain in a container, the exact same rule I just showed in my slides a few minutes before, with the output message, the whole context about the priority, the source, the image ID, everything. He did a match, so he knows, he knew, oh, for this exact event, in the namespace which is not kube system, I have to do so. And what I have to do is to perform the action called label pod as suspicious. With this actioner, you have the result message there. Default has been labeled. The pod CNCF has been labeled. And you can see now the pod has a new label. This label can be really useful for you if you run a CNI, an advanced CNI, to put it in quarantine. Or you can also add a specific label to scrap the metrics with a higher granularity, just for the investigation. Or not every 1 minute, but every 10 seconds, for example. If the pod is suspicious, it is nice to have more details. So now I will install some stuff. That is so big for me. Girl. And we'll see later. Netcat ready. One N in English. So technically, I'm just installing something for after module. And while everything is installed, we can see what I just did has been detected by Falco, forwarded by Falco Psychic to Falco Psychic UI. So we have, it's a little bit slow. The first event was a terminal shell in a container. Then I started a package manager to run apt update. I know it's a little bit small, but I can't zoom in because of JavaScript. But trust me, it's there. I can show you maybe like that.
It's visible, I think. Yeah.
It's visible.
Yeah,
we have the exact path. So we have the exact command I typed, apt update. Then we have the other one, install curl and netcat traditional. And we can see the installation of the package there. So everything is there in Falco Psychic UI. So let's go back to this one. Okay. Now, it's quite classical. When someone got access to a shell inside a pod, it will try to call the Kubernetes API, the control plane, to check if the pod has some rights to perform actions over the cluster. So now I will call the Kubernetes API. Kubernetes default. Okay. I tried to curl the API. In my situation, it was a failure because my network is correctly set. But as you can see, it has been detected by Falco. The alert has been forwarded to Talon, and Talon replaced the label which was suspicious. It has been replaced by compromised. Now we can do another stuff, and I can show you too. Normally, that's it. Yeah, not this one, maybe this one. Oh, it's really slow, sorry. But yeah, you can see on the other side, Talon was also able to notify my team on Slack.
Yeah.
A pod in the pod called CNCF-55 in the default namespace. I tried to reach the Kubernetes API server, so Talon set the label compromised. So we can also have these notifications in Slack from Talon. So another step is, for example, I will now echo hello Steve in /etc cloud native cloud. It has been detected by Talon once again, by Falco, and Talon in that situation downloaded the file. This file has been exported to Minayo, and then the file has been deleted. You see?
Neat.
So technically, I can see. TC, CNC. But in Minayo, if I'm going into the bucket, I have a files folder, and the file is there. You have the timestamp, the namespace, the pod name, and the path of the file. So if I'm opening it, I hope it will work. Wait, see. There.
Look at that. Neat.
Hello
That's
script.
awesome.
So the file is there.
Voila.
It could be a Perl script or something else. And once again, we have everything inside the Falco Cyclic UI, right below etc. And the file is there, etc CNC.
So a question for you, Thomas, with Talon, can you play back the Talon logs back to Falco so that you can then essentially alert on the changes that you've made via Talon, if that makes sense? So you've kind of got an audit log. So you could say, for example, you made a change. Well, you did what you did there, right? You wrote a file to etc. Talon's fired. It's uploaded it to Min.io. It's downloaded. It's deleted the file from the pod. Can I get the logs from those set of actions back through Falco and then out to say like a sim?
It's not the purpose of Falco. Falco is really made to act in real time over a stream. So it's not really the purpose of a sim, because with a sim you can get statistics, for example, rates of alerts and so on. But you can export the Talon logs into the same sim than Falco. It's not an issue.
Okay, that makes
you can
sense.
forward all Talon logs to Elasticsearch, for example, and out of the box we have this element called this field in all logs, trace ID. So if I take a look on the last logs, you can see they are all sharing the same trace ID. So even if you have multiple actions in the logs, with the trace ID, you can follow the steps.
Yeah.
And I will show you another way to follow what action have been made right after. So now I will do another thing, which is Batu. I will, not this moment. I will simulate a reverse shell with netcat. There. I hope it's the correct command. I think so. No. Oh yeah, sorry.
Live demos.
I forgot
You're doing great.
Yeah, exactly. I will zoom in a bit. Yeah, so I will run. Okay, so technically, right now, I'm supposed to be inside the pod. Yeah, the name is correct. I can show you, for example, etc password. For example, it's just an example. I can do whatever. And what we can see on this in this panel from Talon, it's a little bit too big for me. Worse. Yeah. The action was capture the packets with TCP dump. So technically, in the background, when Falco detected the netcat process, Talon was able to start in a few milliseconds a TCP dump capture. And normally, right now in Min.io, we have a TCP dump folder with two captures. The first one was because I missed my netcat command, but technically, if I'm downloading it, this one, where is my folder? There, Wireshark. Just for your information, Wireshark has been created by Lois DeJoani, which is also the creator of Falco. So somewhere in all my desk, I have, okay, Wireshark is there.
There we go.
And follow TCP stream. Okay, and we have everything that went through the netcat reverse shell.
That's awesome.
You name, so request, answer, request, answer. So we collected in real time all events that happened inside the web shell and to be able to investigate after.
Great.
So the last step in that demo, now I will call another domain. So I will just put it there. Let's do there. So we have this running pod. I will call another domain.
If you bump
which
the
is
screen,
shift
maybe on the bottom one, just so that people can see. Yeah, there we go.
Yeah. Okay, so I will call another domain, and my rules of my Falco rules, I just said this IP, the IP for this website. This is a legit website. You can try it after, not worry about that. It's a pretty useful one. You can try it. But I know they have a static IP, so it was easier for my demo. So if I will call that domain, the IP of this domain is noticed as suspicious for Falco, so Falco will detect it, and Talon will terminate the pod if it works. And it will happen in less than 1 millisecond. Normally. It happened correctly. Wow. And so now the pod is not there anymore. And another thing that has been done in the background from Falco is, oh, really huge. I don't know why it fails so much. Oh, better. So I will show you Calico network policy. In the network namespace, we have a fresh new created policy, and this policy will deny all new connections to the suspicious IP.
Smart.
And just to answer your previous questions about how to know what Talon did, I will show you the last step. As said in my slides, Talon is able to expose, to create traces. So in these traces, we have all steps that have been made by Talon. So in this example, we have the event. We also have the whole Falco event there, the match, and the actions and notifications. We also have the checks. For example, it's totally transparent for you, but Talon in the background will perform some checks. For example, he will check before trying to terminate a pod. He will check if the pod still exists or not, just to avoid to try to terminate a pod which is not there anymore.
Makes sense.
We have some. It's totally hidden for the people, but it's really important to avoid strange actions. I would like to see this one. For example, this one. This action is TCP dump. So we have the TCP dump, we have all context, and after we have the output, which is basically the export of the TCP dump of the pickup file. You have the message, the status, success, and all details are there. So you know everything there. Resource attributes, you may have, okay, not relevant, but you have all the steps from the event collection to the final notification. Everything is there in traces, so you know what happened, what Talon made. Everything is supposed to be clear. Awesome. How long it took to do every steps.
Yeah, I can see now why Talon got accepted. Like it's just that missing piece that we wanted, right? You've kind of got the remediation part now kind of locked down, which is great.
Now I'm open to questions. If you can cool. Scan this QR code and not send questions, but feedback, just to tell me, okay, your demo sucks. Your slides are still in French for some of them. Sorry for that.
No problem.
You can scan it.
Cool. I've got a question for you whilst we're waiting for anyone from the audience. Cool. So as Falco continues to evolve, right, as this kind of cloud native, specifically runtime security tool, like how do you envision it integrating with AI and machine learning? Right, AI and machine learning is obviously the new buzzword that everybody talks about nowadays. But I think it can really, it can enhance and give us better kind of threat detection and response mechanisms, right? So is Falco looking, and have they got any plans for that moving forward?
We can use AI on 2 levels. First, at the input level. So basically, it will be to check all syscalls and run some model over the syscalls to detect strange patterns. We have to take care of that just because you keep in mind, Falco is able to collect millions of syscalls per second. I don't know an AI system which is currently able to run something over that rate of events. So another thing is better to use the AI to dig among all Falco alerts to spot the exact the most important ones, to exclude the false positives. For example, it's the most common pattern, and this is what the SysDig Secure product, which is full security solutions made over Falco and other things developed by SysDig. They have for this commercial product AI they call that risk spotlight, able to correlate the CVEs detected by the image scans, and the alerts collected by Falco. They mixed all together to just spot, okay, among these 500 alerts, only these 4 are to be investigated right.
That's the power, right? That's where I think it's really going to help us. So you're probably aware that we have a tradition on the Project Spotlight series whereby the previous guest asks a question for the next guest without necessarily knowing who that is. So Jim Baguadia from Coverno asked,
I know him.
Yeah, how do you feel security is innovating to meet the needs of an ever-demanding cloud-native ecosystem?
This is a good question. Do we have 1 hour to answer? So a thing I saw in the last decade is basically before it's still the case, but less and less. Before, most companies were involved in security for only 2 reasons. When they had some mandatory requirements, the laws for PCI DSS, HDSS or else, or when they have been deeply pwned by attackers. But now, because the world is like that, more and more companies are trying to include security in their process, in their integrations, in their when they are building architectures. Like we saw in the last years, the integration of the FinOps principles to develop architectures. I was FinOps for 3 years, so I know so I know the topic too. And I think this is a good thing, but it still has a cost for companies. Security is a cost center, and it's still hard to get them involved correctly in that field. It's better and better because we have systems quite easy to integrate, like Kyverno. I'm a big fan of Kyverno. The guy who created Policy Reporter for Kyverno is a friend of mine. We created the previous version of Falco Psychic UI together. So you see, it's a small world. I think, yeah, it's evolving in the right direction, but it costs, of course, for the companies. But at least now we have the DevSecOps position, which is a good thing to at least do some evangelism internally in the companies to improve the security.
So as we wrap up, I wanted to make sure that people know how to get involved with the Falco community. So can you just give some advice on ways they can contribute both verbally and also
so you can join us in the Kubernetes Slack channel, Kubernetes Slack. We have a Falco channel. This is the official one. If you are interested by Falco and would like to learn more about it, you can scan this QR code and download for free a PDF written by Loris, creator of Falco, and Leonardo Grasso, the main developer of Falco, the lead developer of Falco. You can download the free PDF. It's a big book, O'Reilly book, so it's a big book about Falco, which explains everything except Talon, because it's too fresh for the book. But a new version will come with that. We have every week a community call on every Wednesday at 4 p.m. UTC. And you can follow us on Twitter. If you need any help, the best way to contact us is the Slack channel. You can ping me any time on Twitter or LinkedIn if you have any questions or any proposal.
That's great.
Or any use case we want to share with the community. I'm always looking for new use cases.
I will. I'll get the information and make sure that we put that in the show notes. So obviously you're aware of the tradition, right? So what question do you want to leave for the next guest? And that could be anything. That could be technical, non-technical, just something that piques your interest.
Yeah, I have a theory I would like to share. Maybe the next speaker can speak about that. I think most of the issues we face in the computer science field are always related of the fact, as humans, it's really hard for us to how to say, to think about the life cycle of our applications. I will explain a little bit about that. Every issue we face about scaling issues, about issues with the CI. For example, the last one from CrowdStrike, when they deployed on Friday a shitty thing. It's always because we didn't think enough or correctly what will be the life cycle of the application. And I would like to know what is the opinion of the next speaker about that quote.
It's a good question. Cool. I'll make sure that I ask the next speaker that. So yeah, I want to wrap up and say thanks so much, Thomas, for joining us today and sharing the insights into Falco, and congratulations on Falco Talon. Looks like the missing piece that I know myself and probably a number of other people have been missing. So yeah, thanks to everyone who tuned in. Don't forget to check out Falco again at falco.org, and stay connected with the Cloud Native Club on Twitter, LinkedIn, and YouTube. And until next time, stay Cloud Native, everyone. Thanks.